are the two little vertical lines. They are not brackets. They are not curved. They are vertical. And they mean, now there's a whole bunch of different definitions. I should say a whole bunch. There's a few different definitions of the absolute value. And if you go on and you take calculus, they will explain all that to you. All right. The only one we're going to concern ourselves with is what is its distance from zero? Okay. So distance, from, I can't even write. Distance from zero. So if you look at this, absolute value of 6, that's how you read that little bit there. Well, here's 0. The distance of 6 from 0 is 6 units. Pretty self-explanatory. Okay. And absolute value of negative 6, well, that's over here on the number line. All right. This distance is also 6 units. So the absolute value of 6 is equal to 6. And the absolute value of negative 6, the distance from 0, is 6 units. Okay? It makes everything that's in, the other way to think of it, a mathematician would, roll over in the grave if they heard me say this, but basically whatever's on the inside of the absolute value sign becomes positive. All right? So, there it is right there. Absolute value of a number will never...
Can I get grade 9s with the last name G and H? G and H to the aviary. Thank you.
Absolute value of a number will never be negative. Okay? So, if I say, what is the absolute value of 3? This one right here. What's my answer?
3.
Just 3. If I say, what's the absolute value of negative 3? You will tell me? Positive 3. Now, C, you always look inside of the absolute value sign. What's the absolute value of 8? Just 8. But there's a negative in front of it. So then we just make it negative 8. And then they start trying to trick you here. So absolute value of negative 8. Start on the inside of the absolute value. What's the absolute value of this? 8. But there's this negative hanging out in front. So the answer is just negative 8. And then you can get into operations. The absolute value of 7 plus the absolute value, the absolute value of negative 7 plus the absolute value of 7. What's the absolute value of negative 7? Plus the absolute value of 7 is? So the answer is? If you have an operation inside the absolute value, do that operation first. It's like brackets. If I had brackets of 1 minus 5, you do what's inside the brackets first, right? BEDMAS would say, or BODMAS, or whatever they call it now, would say that that's negative 4, correct? You do the same thing with absolute value. So 1 minus 5 is negative 4. And then, what's the absolute value of negative 4? 4. And then they start to throw curveballs at you. Always start on the inside. What's the square root of 81? 9. So I get negative of negative 9. And then what's the absolute value of negative 9? 9, but there's this negative hanging out in front, so the answer is just, negative 9. Okay? That's it. That's as tricky as we're going to get here. Can get different levels of orders of magnitude trickier, but we're only going to do that. Is that okay? I would like you to do 1 and 2, please. So go to the questions. There. So page 11. Okay. We're going to look at the graph of the absolute value function. Now, this is one of the definitions here. Absolute value of x is defined as the square root of x squared. You don't need to remember that. Okay, I will never ask you that. If you go on in calculus, like I said before, then yes, that becomes important. But for us, it doesn't. which means, and then you can write it as a piece, what's called a piecewise function because it's broken into pieces. Again, don't need to know for this class. All you need to know is what the graph looks like for this class. And I'm going to tell you that in a sec. If x is positive, the function, the graph of it is x. What is the graph of y is equal to x? If I just said sketch this graph, what type of graph is that? Is it curved? Is it linear? Is it? Sorry? It's linear because the degree is 1, right? What's the slope of that graph? 1, right? Because it's mx plus b. Remember we did that yesterday? So what it's saying is if when x is positive, so all the positive numbers here, the graph is y is equal to x, which looks like that. That's y is equal to x. If x is negative, less than 0, so that's all the numbers on this side, it's equal to negative x, which has a negative slope. So the graph slopes like this. So I'm just going to redraw it here. So this is y is equal to negative x. So the graph of y is equal to absolute value of x looks like this. It's a V centered at the origin. Okay. That's what you need to remember, that it will be a V. Okay. It's similar to in grade 11 when you did this. Y is equal to x squared. What does that graph look like? Parabola centered at the origin, right? Like that. So on the y is equal to x squared, if I said sketch that, x squared plus 1, what does that graph look like? What does the plus 1 do to the graph? It moves it all up, right? 1 unit. So this graph would be, remember we talked about this yesterday briefly? It's going to move it up 1 unit. That would be a 1. So if I write that, absolute value of x plus 1, what does that graph look like? There you go. It's the base graph moved 1 unit up. So it's at 1. What if I did that? Negative absolute value of x. What do you think that negative does? I don't know who said that. Yes, be upside down. Just like negative x squared. Flips the graph upside down like that. A negative there just flips the graph like that. It's exactly the same. All right, and this is going to lead into the next unit, which is all transformations. So what if I have this? What if I give you this from I think grade 11? What does that graph look like? The one I just wrote, this one. What does that plus 1 do to the graph? Left. I don't know who said right, but ask yourself what makes the inside 0? Negative 1. So it moves it to the left 1 unit, and it's still a parabola. It opens up. So what does this graph look like? Not linear, because it's got the absolute value signs. So you know it's going to be a v, but what has happened to the v? It's moved to the left. Same thing. Ask yourself, what makes the inside 0? -1. So it just looks like that. It's the exact same thing. So I could give you this. Negative absolute value of x minus 1 plus 1. So just go step by step. What does this plus 1 do on the outside? This one. It moves it up 1. Okay? So we're up 1. What does the minus 1 on the inside do? What does this do? Moves it 1 to the right, because you ask yourself what makes the inside 0? Positive 1. So it moves it 1 to the right. So we've gone up 1 over 1. Okay? The only other thing we have to account for is the negative on the outside. What does the negative on the outside tell us? So it opens down. So it opens down. And that's the graph. Okay? It's the exact same as the parabolas that you did in grade 11. All right. Anybody know what a square root graph looks like? So we could, well, we can do it here. If I put x into here, so I'm doing this, y is equal to square root of -4. Are you allowed to do square roots of negative numbers? Can't do it. So that's gone, and that's gone. If I put 0 into there, can you square root 0? Can? Yeah. Square root of 0 is 0. If I put 1 in for x, what's the square root of 1? What's the square root of 4? 2. Square root of 9? And 16 is 4. So if I plot this on this graph, 0, 0, 1, 1, 4, 2, 9, and 3, and 16, and 4. That is a positive root graph, positive square root of x. The way I would normally draw it, because you won't have a grid, is if you have y is equal to root x, it just looks like that. Okay, opens to the right. That's it. All right. Is that okay? What's the domain of this graph? Remember, there's domain restrictions when what? I give you 2 cases when there's domain restrictions. What are the 2 cases? Yeah, so if you have an x in the denominator, or you have a square root, or any even root, really. But we'll deal with square roots. Okay? So what numbers are you not allowed to square root? Negative numbers. And if you look at the graph, it doesn't go into the negative region. So we'd say, you can either say x is greater than or equal to 0, or if you want to do the interval notation, 0 to infinity, because we just open to the right. 0 has a square bracket. Why does it have a square bracket? It includes the number, right? Because you can be 0, But you can never get to infinity, so we just put a round bracket because that means it doesn't include that number. Maybe we should do range. What's the range of this graph? The lowest y value is 0, and then it just goes up. So we would say y is greater than or equal to 0. Or if you want to do interval notation, it'd be the same notation, 0 to infinity. All right. Okay. So what does that graph look like? Root x plus 1. Plus 1 is not inside the square root. Yeah, it moves it up 1, just like this one here, right? If the plus 1 or the minus 1 or whatever the number is outside of the function, the square root or the absolute value or the x squared, it moves it up 1. So it's the same graph, except it starts at 1 now, and it opens up. What's the domain of this graph? The domain will be the same, right? Because it starts at 0 and it just goes up to the right. So x is greater than or equal to 0, or 0 to infinity. What's the range, though? What's the lowest y value? 1. And then does it go up or down? It goes up. So the range would be y is greater than or equal to 1, or it's 1 to infinity. So y is equal to root x plus 1. Now the plus 1 is inside the square root. So it's inside the function. It's similar to this one now. What happened on this one? This one I just circled. When it was inside, we had to ask ourselves what made it 0, right? Which was -1, so that moved it to the left. You do the same for this. What makes the inside of this 0? -1. So that means we've started there, and it goes like that. And you can always test a point, especially for square roots. It's pretty straightforward. Test a point on either side of what makes it 0, essentially. So what would be the easiest point in the world to test? Well, -1's going to give you 0. You already know that one. But if I just said pick any number in the world, what would be the easiest? 0. Test 0, right? Put x is equal to 0 in here. What's 0 plus 1? 1. Can you square root 1? So it works. So that means it goes this way. If you tested -2, if you went, you don't have to write this down. If I went x equals -2, and I put that in there, what's -2 plus 1? -1. Can you square root -1? No, so it doesn't work. So you cannot draw the graph that way. Okay, it can only go that way. All right. What's the domain of this graph? Say that again. Sorry. Exactly. It starts at -1 and it gets bigger. So you can say x is greater than or equal to -1, or if you want to do interval notation, -1 to infinity. What's the range? Greater than 0, right? Because it just starts at 0, the y values, and they just go after. So, or 0 to infinity, like that. All right, one more. Actually, do two more. Square root of 2 minus x. So what's the first thing you ask yourself? What makes it 0? What number makes it 0? 2, right? So that means we start at 2. We've gone 2 to the right. Okay. Now, you want to draw it like this. Don't actually draw it, which is a big hint. You want to draw it like that, because that's what all the other ones look like, right? But you need to test a point. What's the easiest point in the world? 0. So test 0, okay? If I go x equals 0, and I plug it into that equation, I get 2 minus 0, which is square root of 2. All I care about, I don't actually care what the answer is. All I care about is, can you do this? Can you square root 2? You punch it in your calculator, you'll get a number, right? 1.41 or something like that. Okay? So you can do it. That means the graph has to go that way. Okay? If you test 3, if you tested 3, and you get 2 minus 3, which is the square root of -1. Can you square root a negative number? No. So you cannot draw the graph going that way. The numbers have to be smaller than 2 because it's 2 minus whatever number you put in. So if the number is bigger than 2, you end up with a negative number. So the graph has to go that way. So what would be a clue to tell you the graph opens the other way? Looking at this equation and looking at this equation. What's sort of the big highlighted difference between these two equations? What's going on with the x?
It's positive in the first one, it's negative in the second one.
There you go. Negative x, positive x. If you have a negative x, odds are you're going to open that way, unless they've hidden it somehow by doing a bunch of other stuff. But we won't really look at those. Okay? So if I give you this, if I give you that equation, I said sketch this. What do you do? Okay, what does this 2 tell you? That's gone up, right? Because it's outside of the square root, just like this one. It's outside the square root. So we went up 2. So let's say that's 2. All right. Then inside the square root, you ask yourself, what do you ask yourself? What makes it 0? What makes it 0? 3. Positive 3. So that means we went 3 to the right. So that is your starting point. Over 3 up 2. Does everybody understand that? Okay. Then you ask yourself, I should test the point. But I just told you, or you figured it out, that there's a little trick. What's the trick? If it's minus x, it will open the other way. So this graph looks like this. Is that okay? Can you tell me the domain and range of those two graphs? I guess the domain and range of that one graph. Did you do it? What's the domain? Less than or equal to? Is that what you were saying? Yeah. What's the range? There you go. So x is less than or equal to 3, because it's going smaller than 3. If you write it in interval notation, because it's going to the negatives, it goes to negative infinity. Smaller number always comes first, and then the bigger number, which has a square bracket. Range, y is greater than or equal to 2, 2 to infinity, square around. Is that okay? All right. Okay, one more. Flip the page here. Sketch the radical function 2x minus 1. Uh-oh. We put a number in front of this x. So, every time you get a square root graph, what do? That has other numbers in it. I don't know what I'm trying to say. What did we do? Here, you said, what makes the inside 0, right? And it's easy when it's a whole number. There's one extra little step here. I ask myself, what makes the inside of that 0? Now, if you don't want to do it in your head, that's fine. You just go 2x minus 1. What makes it 0? Okay. And then you algebra it. I just made that word up. Move the 1 over. Divide off the 2. You get 1/2. Okay? So, positive 1/2, which means we went which way? Right or left? Right. I don't like that graph. We went 1/2 to the right. Okay. Then you ask yourself, does it open to the left or to the right? What's your intuition? You're not allowed to answer. What's your intuition? Left or right? Why? Because the x is not negative, right? Correct? I should probably say. Okay, so we think it's going to go like that. Just test the point to make sure. What's the easiest point in the world to test? 0, right? If you test 0, so if I put 0 into there, and you don't have to write it out, you just kind of do it in your head quickly. It's just a quick test. And I go 2 times 0 minus 1. What's 2 times 0? 0 minus 1 is? Can you square root -1? No. So the graph cannot go that way. It has to open the other way. So we're done. Oh, we got to do the domain and range. What's the domain? Doing interval. Sorry. That. And the range? Oh, my orange toothed friend. Let's go. Perfect. All right. Is that okay? It's basically quadratics, what you learned, except we're changing the functions to square roots and absolute values. That's it. All right. All I want you to do is 7 and 9. I'll give you 5 minutes because it's only a couple questions. Sketch the graph, write the domain and range. I'll put the answers up because the back doesn't have them. So 7 and 9. You don't have to worry about 8. And I'll put the answers up.